Okay, so we're on lesson 4.2, and we're going to talk about polynomials today and end behavior. So end behavior is one of the goals of this lesson. It's really kind of a neat thing we'll learn about on how to sketch a graph using end behavior. So we're going to learn about polynomials in general. So if you have a polynomial like negative 3x squared, that's a monomial, by the way, and the degree is really the exponent of the variable there. So this would be a second degree polynomial, monomial. If you have a polynomial like negative 8, x to the fourth, plus 5, x squared, minus x plus 1. So that's a polynomial. It has 4 terms in this case. And this would be a fourth power polynomial. So fourth degree would be the degree. So you take the largest individual term. You're going to find that we're not going to focus on the rest of these. We focus on the big term, and especially when we talk about end behavior here. So this is fourth degree polynomial. And again, you take the largest individual monomial in there, that's going to determine the degree of the polynomial. So there are certain types of polynomials. One is a constant function. So an example of this might be like y equals 5. The graph is going to be, the type of graph is going to be like a horizontal line. And that is degree. The degree is equal to 0. So it actually doesn't have an x. It would be like x to the 0 power. It's just a constant, just a number there. Linear, like y equals 2x plus 1, is an example of a linear function. It's going to be a straight line also, but in this case it's going to have a slant to it, and the degree of a linear function is equal to 1 because x is to the first power. Quadratic is our second degree. So like y equals negative x squared minus 1, something like that. And the graph of these are going to be of the shape with a parabola, something like that. And so these are all degree 2. Third degree are called cubics. And so like y equals x cubed plus x, it would be a cubic. And the graph may have different looks to it. Sometimes it kind of does this. Starts low, ends high, has a little curve in there in between, and the degree of that polynomial is 3. Quartic, you don't hear that name very often, but you sometimes will see these. So negative 2x to the fourth plus 3x cubed. That would be an example of a quartic. Degree is 4. The graph might look like a W, maybe, or something like that. Doesn't have to have quite that many curves in it, but it might. Quintic is our last one that I want you to see. And so that might be like y equals x to the 5th. The graph of a quintic could look kind of like this. So the degree of this function is 5. You may notice that sometimes I count the number of turns. So like it turns right there, it turns right here, it turns right here, it turns right there. It has 4 turns, but it's 5th degree. This one can turn up to 3 times, and it's 4th degree. This one can turn up to 2 times, and it's 3rd degree. This one always has 1 turn, it's 2nd degree. This one doesn't have a turn, it's linear. So just some things there about types of polynomials. So end behavior is kind of an interesting thing. Let me show you the different cases. Maybe you can kind of think about end behavior this way. So end behavior is when you're thinking about the value of x as it approaches infinity. So here's what I mean. So like for this problem, as x approaches infinity, what is happening to the y value? What is y approaching? So as x gets bigger, can you tell that the y value is also getting bigger here, right? Y equals x. So if x was infinity, y would be infinity. y is certainly approaching infinity if x is approaching infinity. So off to the right here, as x is getting bigger, y is getting bigger. And the reverse is true over here. So x approaches negative infinity. Sorry, maybe I should say it this way. X approaches negative infinity. As x gets smaller, what's happening to the y value? It's also getting smaller. So y is also approaching negative infinity. That's the formal way of talking about end behavior. What's happening to y as x approaches infinity, or as x approaches negative infinity? As we go further left, as we go further right on the graph, what's happening to the y value? Is it getting bigger? Is it getting smaller? Etc. The informal way of saying end behavior is just say something like this, like it starts down and it ends up. And so this end behavior is it starts down, it's going towards negative infinity when x is getting smaller. When x gets bigger, it is going higher and higher and higher, and so it goes up. So watch the pattern here. When we have x to the first, graph has an up down, or let's see, that would be a down up. This one is up and up for x squared. X to the third is down up. X to the fourth is up up. Fifth, down up. Sixth, up up. Seventh, down up. Eighth, up up. Can you see the pattern here? If you put a negative in front of the function, it reverses the pattern. So it starts up and goes down. Negative with an x squared, it goes down, down. Negative x cubed, up, down, 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 up, down, down, down. So there's really four cases. Coming back to you hear about end behavior. So let me put down the four cases we have for end behavior. You need to know each case. I like to think about just basic graphs. Think about this. So if like y equals x, so if it's let's see, if this is a positive value here, so if this is positive, and this is odd. So positive and odd, the graph is going to start low, so down, and end high. So it kind of goes low to high. It's going to have that kind of a look to it. It may squiggle in between, but it's going to start low and end high. If the graph is of something like y equals 2x squared, for example. So this is a positive number here, so this is positive. And this is even. So when it's positive and even, the graph is going to look like this. It's going to be, we would describe it as up, up. And when you have y equals negative x, something like that. In other words, when this is a negative value, so negative and odd, negative and odd always starts high, ends low. So it's going to be up, down. And finally, we have the last case, which is a negative. Let's see, let's go x squared. So this is negative, and this is even. Negative and even always has the same behavior. It looks like that. It's going to be down, down. So those are the four cases. You have to think about the degree. The very first term, the monomial with the largest degree, is going to be that. So like this one, the end behavior is going to be determined by this term. It has the highest degree. That's negative and even, so it's going to be down, down. This one, the largest degree term is this one, so that's negative and odd, so that's going to be up, down. This one is negative and even, so that's going to be down, down. This one's positive and odd, so that's going to be down, up. And this one is positive and even, that's going to be up, up. And this one looks to be negative and odd, down, up. Or sorry, up, down. Sorry. And this one's positive and odd. That's down, up. So, and you might even see it like this, like if you had something like y equals x minus 3 squared times x plus 1. Without multiplying this all out, I know the first term here is going to be x squared and times x, so this is going to be x to the third, plus I don't really care about the rest. So if I just think about that as the first term is x cubed, the end behavior is going to be down, up, right? And they kind of squiggle in the middle. So that's your end behavior stuff. And we use that to find the zeros here on the graph. So let's say we factor this. Right, so we get x plus 4, x minus 1. So solutions are at x equals negative 4, and x equals 1. So x equals negative 4, and x equals 1. So the end behavior of this graph is going to be x squared, so it's even, so it's up and up. So from the right, it's got to go up. From the left, it's got to go up. So I know the graph looks like that. Then we're going to just maybe plug in a value here, like in between here, so maybe negative 2. So if I plugged in a negative 2 to this function, squared plus 3 times negative 2 minus 4, that would be 4 minus 6 minus 4. 4 minus 10 is negative 6. Let's write down here negative 2, negative 6. That probably is the vertex, actually. And it's going to look something roughly like that. You might even be able to find the y-intercept is 1, 2, 3, 4, negative 4 right there. That's the y-intercept of the graph. And you could get a pretty good graph of that. And it's just a sketch, right? We're using end behavior, so there's a little different way of doing it. If you graph it in the calculator, you can see the graph looks something like that, which is a lot like ours look like. Maybe a little bit off, but it's got the general idea. It's got some important points there. It's got the intercepts. So that's the goal of today, is to try to graph things with the zeros of a function. So if you look at your zeros here, x equals 2, x equals negative 3, and x equals 0. So we put zeros there at 0, 2, and negative 3. And end behavior in this one, I know the first term is x to the third. That's positive and odd, so it's going to start low. It's going to end high. And this is where it gets tricky on this one. So what's going to happen in between here? So you can just plug in a value. That's one way of doing this. Let's plug in a value like in between 0 and 2, like 1. So if we did that, we'd get 1 times 1 minus 2 times 1 plus 3. That's equal to 1 times negative 1 is negative 1 times 4 is negative 4. So I get negative 4 there. So 1 negative 4 is down here. So this graph kind of does this. Maybe plug in a value in between these two values, say like negative 1. So we're plugging negative 1 for x, negative 1, 1 minus 2, times negative 1 plus 3. And I get negative 1 times negative 3, that's 3. 3 times 2 is 6. So I think I get a positive 6 there, somewhere up there. Not sure exactly what happens, but it's going to look something roughly like this. I know it goes through those points. It's more of a sketch than a perfect graph. And that's basically what we're doing. So we're using end behavior. That's not too bad. We got the end behavior right. Starts low, kind of squiggles around, ends high, and we got some of those important points correct as well. So another way of doing this, slightly different, is to just get the two solutions here. X equals negative 1, x equals 3, negative 1, 3. The end behavior here, the first term is negative x squared times x is negative x cubed. That's odd, so it's going to start, in this case negative is going to start high, so it's going to be high, and then low, it's going to end low. And so it's got to do something in between. Now I'm not sure what it does. It doesn't cross through anywhere here on the x-axis, so it might kind of bounce up and do that, or it might kind of bounce here and kind of do this. And so it's going to do one of those two things. One way to do that is just to plug in a point like we just did a minute ago. I'm running out of time, but there is a shortcut called multiplicity. If this is 2 or even, it's going to bounce at that negative 1. So it's going to hit negative 1, it's going to bounce up. and then go through over here. If this is odd, it goes through. If it's even, it bounces. We'll talk more